Hey there, Algebra 2. I'm re-recording a lesson 3.1. The one that I've uploaded for you to watch is all wonky. The sound's a mess, and I don't know how to fix it, so we're just going to do it again. We're not going to start with the daily homework quiz, though. Let's start from the beginning. There's our warm-up. So evaluate without using a calculator. This first one right here, 121 is a perfect square. I know that because I have a few of them memorized. If I start high, 9 squared is 81, 10 squared is 100, and 11 squared is 121. So the square root of 121 is 11. 5 to the negative 2, that exponent tells me to drop the 5 to downstairs to the denominator, and then I can square it. Solve this, write the answer with radicals in simplest form. We did this in chapter, I think chapter 1, and then again a little bit in chapter 2. The opposite of a square is a square root. So I can say x plus 7 is equal to plus or minus root 24. Now 24 is not a perfect square, but I can rationalize it. 2 times 12, 2 times 6, 2 times 3. I have a pair of 2's, so a 2 can come out, and I had a 6 left over. So x plus 7 equals plus or minus square root 2, plus or minus 2 root 6. I can then, I'm running out of space, let me change colors to make sure we can see it. Subtract 7 from both sides, and I have x equals negative 7 plus or minus 2 root 6. That is a radical in simplest form. Let's go back. Red's such an angry color. A ball has a surface area S of 1,253 square inches. Use the formula R equals 1 over 3.54 times root S to find the radius of the ball. So I think surface area is equal to, let's see, I would move this over, 3.54 R squared. That has to be some different formula. That's really not right. They've already solved it for R. We don't need to know this. I was just trying to make sense of that equation. So I know the surface area is 1,253. So I'm just going to substitute and then calculate. Radical 1,253 divide by 3.54. I have a radius of 9.999 or approximately 10. And I can say approximately. All right, let's get into the meat of the lesson. All right. You can extend the concept of a square root to other types of roots. For example, 2 is a cubed root of 8 because 2 cubed equals 8. In general, for an integer n greater than 1, if b to the n equals a, then b is the nth root of a. An nth root of a is written as, n goes right there, square root a, where n is the index of the radical. We will say things like root 4 equals 2. I will never, ever, ever write that's a square root. Whenever you see a radical with nothing there, it means it's a square root. If you see a radical with a 3 there, it's a cubed root. A 5, a 4, an 8, it doesn't matter. But if it's empty, it's a square root. You can also apply an nth root of a as a power of a. If you assume the power of a power property applies to rational exponents, then the following is true. If I have a square root of a, that's not very legible. Let's write that again. I'm going to write a, and it's a square root. If it's a to the 1/2, I can actually make this If I square this, reset, I have a square root of a, and if I square that, it is equal to a. What this is saying is I can rewrite this radical as a to the 1/2 and square it, I get a. If I have a cubed root of a and I cube it, that equals a because it's the same as a to the 1/3 cubed. I can write my radicals as exponential functions, okay? That's a lot of words. Here we go. The nth roots of a. Let n be an integer greater than 1, and let a be a real number. N is an even integer. N is an odd integer. So when a is less than 0, I have no real nth roots because that'd be a negative a. That means they're imaginary. When a equals 0, there's one real nth root and it's 0. And then when a is greater than 0, it's positive. I have 2 real nth roots. This was no real. Okay? And that's when it's even, like 2, 4, etc. Here, when n is an odd integer, so it's like a cubed root, and a is less than 0, I actually have one real nth root. When I still have odd, it can be any odd number, 0, I have one real. And when it's positive, I have one real. Okay, the kicker here is we know that when it's negative, I only have imaginary answers. But when it's odd and it's negative, it's okay because -2 times -2 times -2 equals -8. So the cubed root of -8 equals -2. I have one real. All right, find the indicated real nth roots of 8. When n equals 3 and a equals -216, that's what we're doing, all right? It's the same as that, all right? So I have one real cubed root, and I know that, actually, let's just go here. You can either find the cubed root. So I'm going to hit math and arrow down until I see the cubed root. And I'm going to type in -216 and I get -6. Fourth root of 81. It doesn't do fourth roots. I'm going to pause it and bring up my calculator. So here, if you hit the math button, actually, second quit, I'm going to hit the 4 first, and then the math button, and number 5 right there. It makes it a fourth root. I have a fourth root of 81, hit enter, it's 3. All right, rational exponents. We've talked about this a little bit already. A rational exponent does not have to be in the form of 1/n. Other rational exponents, such as 2/3, -1/2, etc., can be used as exponents. 2 properties of rational exponents are shown below. So we had square root of a is the same as a to the 1/2. What we're saying is nth root of a is a to the 1/n. All right? Now what's cool is I can say square root of a to the 3rd power is a to the 3/2 because it's the same as a to the 1/2 times 3. Okay, same with this one. If I have a to the m power and I take the nth root of it, it's the same as a to the m times 1/n which is the same as a to the m over n. Okay, because you multiply those. We learned that already. All right, so let's evaluate expressions with rational exponents. And for these, I'm going to mess around a little bit. 16 to the 3 halves. It's the same as 16. Let's not do that. 1/2 cubed. Okay, that's the square root of 16 cubed. I'm giving you many options. The square root of 16 is 4. Cubed is 64. I do some math in my head. All right, so you have to know what all these numbers do. Here I have 32 to the negative 3/5. Okay, lots of things I can do here. That negative tells me to put it in the denominator. Positive 3/5. Okay, that's also the 5th root of 32 cubed. What is the 5th root of 32? 5, math, number 5, 32. It's 2. So 1 over 2 cubed is 1 over 8. Okay, approximate roots with a calculator. All right, I'm going to show you, not use those keystrokes. 9 to the 1/5, we really are doing 9 raised to the 1 divided by 5. Got it? Okay, 12 to the 3/8, 12 raised to the 3 divided by 8. Rocket science, I know. Ooh, this one you have to mess with a little bit. Okay, it's the 4th root of 7 raised to the 3rd power, so it's 7, 1/4 times 3, which is 7 to the 3/4. 7 raised to the 3 divided by 4. Cool? Easy peasy. All right, guided practice. I'm going to go ahead and push pause and just write out the answers because these are the extra practices. All right, check out the answers. I'm going to push pause again. Cool. Moving on. I'm going to push pause again. All right, number 6 we're going to look at. Okay, I'm going to type in 9 raised to the negative, nope, negative 1/2. Okay, don't give me that as an answer, please. I guess you could round it, but I'd rather you give me a fraction. Math. Number 1 is frac, hit enter, and it changes that answer into a fraction. 1/3. Cool? Cool. All right, I'm going to push pause again. Oh, this one was without using a calculator. Okay, I apologize. I shouldn't have used a calculator on that one. It would have been 1 over 9 to the 1/2, which is 1 over 3. All right, I used a calculator. I didn't read the instructions. Number 5 would be the square root of 4 raised to the 5th power. So it's 2 to the 5th power, which is 32. Yeah. And this is still without using a calculator. So I have the 4th root of 81 cubed. The 4th root of 81 is 3. Cubed is 27. Yep. And then, 8th root of 1 raised to the 7th power is still 1. It says round, so we can use a calculator. All right, there you go. You can push pause and look at them real quick if you'd like. All right, example 4. Oh, this program does that a lot. It'll skip back to the beginning at random times, which is very annoying. All right, example 4, solving equations with nth roots. We've done this a little bit earlier on in our curriculum. We really need to isolate the variable first. So I need to isolate this which means I need to divide both sides by 4. So I have x to the 5th equals 128 divided by 4, which is 32. Then do the opposite of the radical. I'm going to take the 5th root of both sides. Okay, I could also write it like this. I need to take the 5th root of both sides, because that right there, x to the 5th times 1/5 gives me just x. Okay. With odd, we can get just positive or just negative answers, so we don't have to worry about the plus or minus. Sorry, I'm talking and trying to type at the same time. Not always the best idea. So x equals 2, and it can't be negative because I have an odd power. It can only be positive. All right, you can always grab your calculator and check that out. If I do negative 2 raised to the 5th power, I get negative 32. And if I do 2 raised to the 5th power, I get positive 32. It can only be positive 32. Okay, here I have an even power, so I want the opposite of the 4th power, so I'm going to do the 4th root, which also means I can do x minus 3 to the 4th power to the 1/4, because that gives me just x minus 3 equals, I don't think I can do the 4th root of 21. Makes no sense. Nope, so we're going to leave it. Just as the 4th root of 21. And because that's even, it has to be plus or minus. Okay? Has to be. So now I'm going to add 3 to both sides, and I get x equals 3 plus or minus the 4th root of 21. Or if I did it this way, I'd have x equals 3 plus or minus 21 raised to the 1/4 power. Okay? If I went ahead and calculated that, depending on what the instructions were, I would do 3 plus 21 raised to the 1/4 power. I should show you that. I would do 3 plus, and I'm just going to go 21 raised to the 1/4 power. Arrow over, close my parentheses. Okay, so 5.14. I have to go again because it's minus. I'm going to go up here and grab that, change that into a minus because it's easier than typing the whole thing out. 0.86. Those are correct. That's correct. That's correct. The instructions didn't tell me to leave it in radical form, so I'm not gonna. All right, use nth roots in problem solving. A study determined that the weight, W in grams, of coral cod near Palawan Island, Philippines, can be approximated using this model, where L is the coral rod's length in centimeters. Estimate the length of a coral rod that weighs 200 grams. So I know the weight is 200 grams, and estimate the length. So first I'm going to isolate L. So 200 divided by 0.0167 gives me 11,976. I'll give 2 decimal places. L cubed. And then I'm going to take the cubed root of both sides. A positive has to be positive when it's odd. So my calculator, I'm just going to raise my answer to the 1/3 power. And I get length equals 22.88 centimeters. Yeah. Not too bad. I gave an extra page just in case I needed more room to work. Solve the equation. All right, these are the guided practices I usually push pause on, but it's okay. So cubed root, when it's an odd power, the sign stays. So a positive number is going to give you a positive answer. I want to isolate the x first, so divide both sides by 1/2. I have x to the 5th power equals 1024. So 5th root. Again, it's an odd power, so my positive answer is going to remain positive. Keep on going. 1008 divided by 3 gives me 36, so x squared equals 36. Square to both sides. It's an even power, so I have to include the positive and the negative answer. Divide both sides by 1/4. I have x cubed equals 8. Cubed root. It's an odd power, so it stays positive. So many of these. Cubed root, it's an odd power, so a negative cubed root stays negative. We're going to approximate, so I'm actually going to type in cubed root of -14. Actually, let me show you the calculator. You guys have got to not make these mistakes. All right, I'm going to do it wrong. -14 raised, raised to the 1/3 power. But it's not going to matter with this one. Dang it. All right, don't do this. All right, please, for the love of everything, put parentheses when you are doing anything radical. Okay, every time. You will keep on getting wrong answers. I saw it in the last test I graded, and I'll tell you why. All right, let's do this one, except square root. That's not correct. It's wrong. It's wrong every time. And then we'll do this one, square root. I can't do a square root of a negative number, so it tells me it's a non-real answer. All right? So this right here is wrong. Put it in parentheses. All right, public service announcement for the day. I don't even remember what it was. Let's see. Cubed root of -14 is -2.41. Add 2 to both sides. I have x equals 0.41. And then the 4th root. Here it's an even, so I get positive and negative. 16 raised to the 4th power. Sorry, calculator issues. What am I doing? There we go. 16 raised to the 4th power is 2. I knew that. Subtract 5 from both sides. I have x equals -5 plus or minus 2. -5 plus 2 is -3. -5 minus 2 is -7. And what if we use the information from example 5 to estimate the length of a coral rod that has the given weight? It was weight equals 0.0. Let's see if I have it here. I don't want to go back and look. 0.0167. Length cubed. All right, I'm going to pause and do these. All right, there you go. Guided practice. Okay, daily homework quiz. I'm not going to do those live either. It's a great way to test yourself, so I'll push pause and give you the answers to these. There you go. Push pause and check them out. Be right back. There you go. Nothing too crazy. And that's it. Good job today.